Okay, so we're going to do 22-2 trig equations. Some of this is review, and some of it's using the trig identities we learned from yesterday. So I'm going to go through this one, try to go quickly because it's kind of long. And then I'm going to do a video of reteaching yesterday's and answering some of your questions that I got feedback on. So I will do that after I do this. Okay, so I'm going to try to skim around because some of this is review. So consider the equation 2 sine theta minus 1 equals 0. Sketch the graph. So I thought this would be a good one just to remind ourselves how to graph these. I thought this would be good. Okay, so we know that it's, the unit circle's in force. So I'm just going to cut this into force very quickly. And then it's down 1. So you know the new midline is down 1. And sine function starts at 0, 0. So I know it's going to start there. And it stretches by 2. Well, 0 times 2 is still 0. Okay, then the next point is going to be put it here. And then you'll go up at 1. You're at 1. And then times 2. So 1 times 2 is 2. So when you start here, it's 1, 2. And halfway you're at the midline. And here you're at the midline, right? And then you go stretch by 2. So you're at 1 because you go down 1. Not down 1. It starts at 1 because it's 0 and then at 1. So then at 1 times 2 is 2. So you go down 2. So the graph looks like this. Because then we're on a sine function. It's at 0, 0. And then at 1, 0, negative 1, 1. And then so it's 1 times 2. That's why I counted up 2 from the midline. Because it's the amplitude. The 2 is the amplitude of the wave. Okay, just a quick review of how to graph. Because it's down 1, vertical stretch up 2. And then it says, how do you know? Use a graph, explain why there must be 2 solutions to the equation on the interval between 0 and 360, which is between 0 and 2 pi. Well, it hits right here 2 times. So intersects y equals 0 twice. But you can see it, 1, 2. And then it says determine the solution and then check with the identities. So then this is determine the solutions of 2 sines. I just did, from here you can know it's sine theta equals a half. If you check your unit circle, that would be at 30 degrees and 150. So you can check your unit circle, get that really quickly. And then it says use your identities. Well, if I plug in sine of 30, well, that'd be 180 minus 30, which is 150. So that gives you sine theta of 30, and then 180 minus 30 is 150. So these identities does support what we found on the unit circle. D is repetitive. Okay, E, same thing. If you work this out, you'll get sine theta equals negative 1 over square root of 2. If you rationalize the denominator, you'll get square root of 2 over 2 with negative. So where on the unit circle is sine square root of 2 over 2 negative? Well, that's at 225 and 315. But if you use the trig identities, the trig identity is sine theta. It tells you right here. Here's one of them. Equals sine 180 minus theta. So if I have sine theta is 225, so I'm trying to use identities to prove it. So sine theta is 225. That's what we found. We can find the other one. So that would be sine of 180 minus 225, right? Which that would be sine of negative 45. Well, if you go in your unit circle, sine of negative 45 is right here. It's right there, which is 315 degrees. Because it says between 0 and 360. Well, between 0 and 360 means you're going to go counterclockwise. So the coterminal angle of negative 45 degrees is, if you go around the other way, is 315 degrees. So this identity does work. Let's keep moving. Number 2, find the between 0 and 360. So this one, you have 1 over square root of 3. If you rationalize it, you'll get square root of 3 over 3. I used my unit circle. And when I used my unit circle, I found that was at 30 degrees. And 210. We've done these before. That's why I'm going kind of fast because we've done these. So you have to use your unit circle, which I did here. Like I used the ratio of the sides to figure out which one was which. Okay, well then if you use the tangent identity, tangent identity is what? Tangent theta equals tangent of 180 plus theta. Well, if tangent theta is 30, 180 plus 30 is 210. So that is true. Same thing here. This one was cosine equals negative 3 square root of 3 over 2. Where does that exist at? That exists at 150 and 210. If you could look at the unit circle, right? Well, if you use the identities that we learned is cosine theta is the same thing as cosine of negative theta. That's what we learned on yesterday's notes. So let's look. If cosine theta is 150, well, if I go negative 150, I'll end up at 210. So this is negative 100. Oh, I'm sorry. Yeah, negative 150. Yeah. So negative 150 would be here, which if you go counterclockwise is 210 degrees. So it works. This one is no solution because it's not in the range. It's outside the range of 0, 360. So sine equals 3 is outside. So there's no solution. Okay, let's try 3. 3 is repetitive. We've done 3 before, so I'm just going to do one of them. Let's just practice factoring. So it'd be 2 sine minus 1 times 2 sine plus 1. So it's a difference of squares. So where is sine theta equal a half and negative a half? Well, you can reference your unit circle and then use your trig identities if you want. So it's pi 6, 5 pi 6, 7 pi 6, 11 pi 6. So by using the unit circle, we've done this a lot. You could also incorporate your trig identities by if you have pi 6, you would subtract maybe 180 minus theta would give you 5 pi 6. So you can go back and use the trig identities if you like, and it checks. Next page, quickly. Okay, thought this was good. It says when there's more than one trig function in particular, the strategy is to write them in the same function. All right, so I thought I would do number 4. Well, we've done 4 before. 4 is repetitive, so I'm tempted not to do it. I'll do it really fast. So 4 is cosine squared theta equals 1 minus sine theta. Well, I know cosine squared theta right here is the same thing as 1 minus sine squared theta. So 1 minus sine squared theta equals 1 minus sine. The 1's cross out because it's the same on both sides. So then I have 0 equals sine squared minus sine. Put everything on one side. The GCF. Take the GCF out. I'm left with sine minus 1. So where does sine equal 0 and sine equal 1? So sine equals 0 at 0 degrees and 180. And sine equals 1 and 90. So just more practice solving trig equations. All right, and then we'll do 5a and b. So 5a is just to practice using the trig identities that was on the last test. So this is good practice from the last test. So cosecant is 1 over sine minus sine. Okay, in my mind, I put it over 1 because I get a common denominator. So the common denominator is sine. So it'll be 1 over sine x, not sine, minus sine squared over sine. So then 1 minus sine squared, we already know is 1 minus sine squared is cosine squared. So 1 minus sine squared all over sine is cosine squared over sine. Well, that's the same thing as cosine over sine times cosine, which is the same thing as cotangent cosine. That's what I came up with. And if you set each one equal to 0, it's actually the same thing, right? Because cotangent, you want cotangent to be equal to 0, which would be 0 over 1, which would be at pi halves and 3 pi halves. And that happens to be the same place where cosine is 0. Cosine is also 0 at pi halves and 3 pi halves. 5b is tangent squared theta equals 1 minus secant theta. Here again, if you have this little sheet out or your cheat sheet, tangent squared theta equals secant squared minus 1. So secant squared minus 1. Substitute. So secant squared theta minus 1 equals 1 minus secant theta. Set it equal to 0. So plus secant theta minus 2, because subtract the 1 over. Then you'll factor. So it's going to be times 2, so plus 2 minus 1, the bigger number. So secant equals negative 2, secant equals 1. But that's not on the unit circle, so it has to be cosine. So cosine, you want to flip it, so negative 1/2. And then cosine this flipped is just same thing. So where is it negative 1/2? Well, it's at 2 pi thirds and 4 pi thirds. So right here is really, and this is at 0. Cosine is 1 at 0. So right here, all we're doing right in this lesson is just practicing using our trig, solving trig equations by substituting in trig identities. So let's keep moving because you can pause the video. Let's try to keep it moving. All right, now I'm going to do 7. Now 7 talks about general expressions. So square root of 2 sine theta plus 1. So it's going to be sine theta equals negative 1 over square root of 2, which we know will be negative square root of 2 over 2. So where is sine square root of 2 over 2? Well, if I go to my unit circle, square root of 2 over 2 sine is at, let's see, just joking. Negative square root of 2 over 2 is down here. So 225. So at 225 is where it'll be at. So Springboard's a little weird. They use degrees on this one. I looked at the answer key. So either way is correct. You can do 225 degrees plus 360 degree K. And then the other one is at 315 degrees plus 360 degree K. Let me look at the instructions. The instructions say between negative infinity to infinity. So it doesn't say in degree or radian mode. So you can use either one. So unless I'm specific, it doesn't give details. So or you could put instead of 225, what could you put? You could put 5 pi fourths plus 2 pi k, which is what we're used to. Instead of 315, you can put 7 pi fourths plus 2 pi k. But then don't forget, you need to put k is an integer. Okay, so this is in degree mode, this is in radian mode, and the homework doesn't say, it just says between negative infinity and infinity. So now the interval is between negative infinity to infinity, which means it's everything that can exist. That's why we use the general solution. Okay, 7b, 2 tangent squared minus tangent theta. So we'll factor it. So 2 tangent minus 3 tangent plus 1. So where does tangent equals 3/2? Where does tangent equal negative 1? My handwriting is so messy. I'm trying to hurry so the video isn't so long. Okay, so this one, since it says on the interval of 0 to negative pi, since you're between negative pi and, negative infinity to infinity, there's no restrictions on the domain and range. So on tangent, the domain has a restriction and the range is open. So it could be anything. Well, this one could be anything. So you have to do inverse tangent of 3/2 and inverse tangent of negative 1. Or you can just use the unit circle on this one. I use the unit circle on that one. So in the unit circle, where is it negative 1? I said 135 degrees is where it's negative 1, because that's where square root 2 over 2 over square root 2 over 2. And then you can say, and then remember the period on tangent is pi, so 180 degrees K. Or I actually said it's 3 pi fourths plus pi K. And then where K is an integer. Okay, this is the unit circle one right here. This one, though, since there's no restrictions, negative infinity to infinity, I use the inverse tan on the calculator. And when you do that on the calculator, you get 56.310 plus 180 degree K. So you just have to be careful. If you're going to put it in degree mode, it'd be that answer. And I actually didn't do radian mode on that one. But you can do that. I know y'all can do that. Okay. So that was a quick overview. I think I did enough to help you with the homework. If not, send me feedback, and that's what we'll do tomorrow. So go through this, and then send me your questions on homework, and then I'll make a video for tomorrow's lessons. And then right now, I'm going to go make a video of the questions that I got from yesterday's lesson. So I hope it's going okay. I know not being there is kind of hard. So just send me emails and give me feedback and I'll make more videos. Okay, thanks.